When we are solving a system of equations by graphing, we are going to graph both equations on the same coordinate grid and then look for the point of intersection. That point of intersection is the solution to the system. So here's our first example. The first system, y equals negative 1/3 x plus 2 and y equals negative 2x minus 3. Both of these are already in slope-intercept form, and both have already been graphed for us. First equation has a y-intercept of 2 and a slope of negative 1/3 down 1 over 3. Second equation has a y-intercept of 0, negative 3, and a slope of negative 2 down 2 over 1. Now, as you can see in this particular example, the point of intersection, that is what we are looking for. The point of intersection is to the left of the y-axis, an x value that is negative. That means that we had to not just graph the points to the right of the y-axis, but we also need to always graph all of the points to the left of the y-axis so that we can have a precise point of intersection. The point of intersection here is x equals negative 3, y equals 3. It is really important and a common mistake for students to graph both lines and then to not write what the solution is. So you need to make sure that you write the solution as an ordered pair. If we mentally check our solution, let's go ahead and do that. Negative 1/3 times negative 3 is positive 1. Positive 1 plus 2 is 3. Yep. And then negative 2 times negative 3 is positive 6. Positive 6 minus 3 is 3. That's a really great thing to do just to check to make sure that our solution that we found graphically is in fact our solution. So here is our second system that we are going to graph both equations and then find the point of intersection. So this first one has a y-intercept of 0, 4, and then a slope of negative 1/2. So I'm going to go down 1 over 2, down 1 over 2, down 1 over 2, and then backwards, up 1, left 2, up 1, left 2, up 1, left 2. So then I can graph or connect those points with a straight edge and arrows. Now this second equation we chose because we could graph it since it's in standard form using intercepts. So just mentally I can see that the x-intercept is going to be negative 4, 0. If I make y equal to 0, that leaves me with x equals negative 4. And then finding the y-intercept, set x equal to 0, so negative 2y equals negative 4. And then I could have found that right here. Oh, no, positive 2. Positive 2. Positive 2 is my y-intercept. So this isn't so bad. I can probably see if I connect those accurately that this is the point of intersection. But the further the point of intersection is from the intercepts, the less precise my standard form graphing will be. So that's why in our instructions we say make sure both equations are written in slope-intercept form. So you could graph it using intercepts, but it just won't be very precise. All right, so let's write this. Let's transform this into slope-intercept form. Negative 2y equals negative x minus 4. Divide that by negative 2, and I get y equals 1/2 x plus 2. Alternatively, if I really like graphing by intercepts, I could have some students do this. I can graph the intercepts, and then I can kind of visually see the slope and fill in those points. That's fine. Or right here, I officially transformed it into slope-intercept form, and I can graph there. So my y-intercept is 0, 2, and then I'm going to go up 1 over 2, up 1 over 2, up 1 over 2. All right. I guess I don't really need to actually draw the line. Oops, but I will. Straight edge, and then that gives me my point of intersection right here. My point of intersection is 2, 3. So my solution to my system is x equals 2, y equals 3, which I want to always remember to write as an ordered pair. Checking that, negative 1/2 times 2 is negative 1. Negative 1 plus 4 is 3. Yes. X equals 2. 2 minus 2 times 3, 2 minus 6 is in fact negative 4. So my solution that I found graphically is correct. The reason the point of intersection is the solution is that point of intersection is the only point that lies both on this line and on this line. So the point of intersection is the ordered pair that makes this equation true, meaning it lies on this line, and it makes this equation true, meaning it lies on this line. Similarly here, the point of intersection is the only point that lies on both lines. That means it makes both equations true and is my solution to my system.